Hello students, this is Mrs. Gregorio, and today we are covering Big Ideas, Lesson 2.3, Subtracting Rational Numbers. Follow along with me in your textbook on page 60. The key idea of subtracting rational numbers is to subtract rational numbers, use the same rules for signs as you use for integers. Here's the rule. Keep the first integer the same, then you add the opposite. Go ahead and pause the video to write this down. Now, example 1 is on page 60, subtracting rational numbers. Find negative 4 and 1/7 minus negative 6 over 7. Before we begin, I'm going to use mental math to estimate. Negative 4 and 1/7 is very close to negative 4 minus negative. Now, 6 over 7 is close to 7 over 7, which would make it negative 1. Negative 4 plus the opposite of negative 1 is positive 1 is negative 3. So I'm going to estimate it at about negative 3. Now I'm going to do the standard algorithm. Negative 4 and 1 over 7, I'm going to rewrite as 28 plus 1 more is 29 over 7. I changed the mixed number into an improper fraction. Now I'm going to add the opposite. Change the minus to a plus sign. The opposite of negative 6 over 7 is positive 6 over 7. Since they have different signs, I subtract and keep the sign of the bigger number. 29 minus 6 is 23. Keep the sign of the bigger number. Over, and now the denominator is 7, so I'm going to leave it alone. Now, 7 can go into 23 3 whole times. I'll show my work over here. And it's going to be negative. 7 times 3 is 21 with 2 left over. So it's going to be negative 3 and 2 over 7. And negative 3 and 2 over 7 is very close to what we estimated at negative 3. So I think our answer is correct. If you want to double check, you can create a number line, divide it into sevenths, and scale the number line to land on negative 3 and 2/7. Now, example 2 is very similar. This time we have decimals instead of fractions. For the decimal, we have 12.8 minus 21.6. I'm going to start with mental math. 12.8 is almost 13 minus 21.6 is closer to 22. Remember, the rules for subtracting integers means you add the opposite. And 13 plus negative 22, they have different signs. So subtracting 22, take away 13 is 9. Keep the sign of the bigger number. It's negative. So our answer is approximately going to be about negative 9. Now let's check. 12.8 plus the opposite of 21 is negative 21.6. They have different signs, so I'm going to subtract. I line it up vertically. Then I'll keep the sign of the bigger number. Regroup here. 16, take away 8 is 8. Bring down the decimal. I cannot do 2, take 0, take away 2, so regroup again. 10, take away 2 is 8. And that's 0. Keep the sign of the bigger number, so 21 is the larger absolute value. Our answer is negative 8.8, which is very close to negative 9, what we estimated. You can also check this on a number line using tenths. I'd like you to pause the video and complete these 6 questions and write in your answer. Now, example 3 is on page 61. Find the distance between the two numbers on the number line. To find the distance, we need to subtract. I'm going to start at 2 and 1/3, and I'm going to subtract the second value, which is negative 2 and 2/3. Remember the rules for adding integers. You add the opposite. The opposite of negative 2 and 2/3 is positive 2 and 2/3. Now, I have a couple different options of how I want to add these. I can leave them as mixed numbers. I know 2 plus 2 equals 4. And I know 1/3 plus 2/3 equals 3/3, which is really 1 whole. So 4 3/3, or 4 plus 3/3, means 4 plus 1 is 5. The other option is to change it into improper fractions. 3 times 2 is 6 plus 1 more is 7. Keep the denominator the same. Plus 3 times 2 is 6 plus 2 more is 8. Keep the denominator the same. Now that there's a common denominator, 7 plus 8 is 15 over 3. 15 divided by 3 still equals 5. So no matter how you solve it, you get the same answer. Remember, distance is always positive. So make sure if you solved it differently, I know our textbook solved it slightly differently. They know that distance is always positive, so they kept our answer positive 5. There are a total of 5 spots, 5 whole numbers, 1, 2, 3, 4, 5 between those two values. You can use the number line to check your answer, and pause the video if you need more time to copy this down. Example 4 is a real-life application. This is on page 61. Here we have a bridge, and the clearance for this bridge is 11 feet and 8 inches. Just thinking about that in terms of decimals, I see decimals in this word problem. 11 feet and 8 inches means 8 inches out of 12 inches in a foot. If I wanted to reduce that, divide by 4, I get 11 2/3, or 11.6 repeating. So as a decimal, the boat has to enter into this bridge, which is 11.6 feet. Now it says in water, the bottom of the boat is 2.1 feet below the surface. The top of the boat is 8.7 feet above surface. So here's my boat. I'm just going to do a quick drawing. From here to here is 8.7. And in the water, pretend this is water, there is 2 feet. There's a better drawing of the boat that's below the water, so it floats. So that's negative 2.1. The total height from top to bottom is 8.7 minus negative 2.1. Keep the first number the same and add the opposite. That becomes 10.8 feet tall for the height of the boat. Now, when you tow the boat on a trailer, the bottom of the boat is raised 1.3 feet above the ground. So I'm going to take the height of the boat and add 1.3. Line up your decimals, and you get 12.1 feet with the trailer. 12.1 feet is greater than 11.6. So if it's taller, the boat is going to be above the bridge, and it will not fit. It will not make the clearance, so the boat cannot pass under the bridge. On your own, solve 7 and 8 and write down your answer. And your exit ticket is to explain how subtraction of rational numbers is similar to subtraction of integers. Pause the video to write out these problems. And tomorrow in class, make sure you have your Wrap Journal, your Chromebook fully charged, and bring any questions you have from this video. I hope you have a great evening, and I'll see you tomorrow. Bye-bye.